All right, since people are going to be taking this test at different times, I'm just going to post a chapter review for you guys. And so looking at this first problem, it says 2 1/2 multiplied by 3 1/3. We could change it to an improper fraction, multiply across the top and the bottom, and then reduce it to a mixed number again. Or I'm going to use a rectangle. This is a method that our book goes over, and so I thought I'd detail it here. So now I'm going to divide this into 4 parts, or quadrants. And here I have 2 1/2 at the top, and then I have 3 1/3 on the side. And so I'm going to start off by doing 2 times 3 for this first box. That'll give me 6. Then I do 2 times 1/3. And if I do 2 times 1/3, I could also think of that as 1/3 times 2 over 1. And so I can multiply across the top and get 2, multiply across the bottom and get 3. And so I get 2/3. And I'm going to go ahead and erase that multiplication I did. So I have 2/3 in that box. And then I'm going to go 3 times 1/2. I do the same thing, multiply across the top. And then I get 3 on top and then 2 on the bottom. Or simply put 1 1/2. But I'll put 3 2/3 here too. Maybe that'll be useful. And then I have 1/2 times 1/3. And so if I do that and multiply across the top and get 1, multiply across the bottom and get 6. And so now I have 6, 1 1/2, 2 over 3, and 1 over 6. So now I need to add these all together. So let's do 6 plus 1, right? 6 and 1, and that'll give me 7. So now I got my whole numbers out of the way. And now let's deal with these stingy fractions here. We're going to add those together. So now I'm going to do 2/3 plus, you know what I should do first? I should make these common denominator. Wouldn't that make life a lot easier? So 2/3, that's going to transform into something over 6, because 2, 3, and 6 all go into 6. So put it over 6. That 2 right here would transform into a 4, right? Because multiply 3 by 2 to get to 6, multiply 2 by 2 to get to 4. And now I'm going to take a look at 1 over 2. Well, that's going to change to 3 on the top and 6 on the bottom. Multiply each by 3. And then I'm going to leave that last one as 1 over 6. So now if I add these all together, I'm going to do 4 plus 3 is 7. 4 plus 3 is 7. 7 plus 1 is 8. And so now it's going to be 8 over 6. And this reduces, or goes into a mixed number of 1 1/3, right? 1 2/6, but then that 2/6 changes into 1/3. So now I'm going to take this, I'm going to add it onto my 7. So if I do 7 plus 1 1/3, that's going to leave me with 8 1/3. So there would be my final answer using the rectangle method. Otherwise, you could do, like I said, improper fraction, multiply across top, multiply across bottom, and then transform it into a mixed number. All right, here we go. We have 3 5/6 minus 2 3/4. And so first things first, I'm going to do my 3 minus 2. So 3 minus 2 is going to give me 1. And now I'm going to do the fractions. Okay, so this is my whole number. I'm going to do my fractions. And I'm going to do 5 over 6 and 3 over 4. What do they both go into? What do 6 and 4 both go into? Well, they both go into 12. So instead of doing 5 over 6, I'm going to do 10 over 6 minus, well, instead of doing 3 over 4, I'm going to do 4 goes into 12, 3 would go into 9, multiplying both by 3, and then 10 minus 9 is going to give us 1 over 12. So here we have 1 from the 3 minus 2, and then we have 1 over 12 from the fractions subtracting. So 1 and 1/12 would be my answer here. All right, turn 2/9 into a decimal using long division. Does it terminate or repeat? Okay, so long division, here's where we need a little bit of room. I'll just write small to start. So here we have 2 divided by 9. And first we're looking at, does 9 go into 2? No, it does not. It's definitely bigger than 2. So we're going to write 0 up top. And then since I have 2 here, I can just write a decimal afterwards and then write zeros, because that's the same thing as a regular 2, right? 2.000, the same thing as 2. And so now I'm going to say, okay, does 9 go into 20? And yes, it does. Goes in there twice. Multiply that by 9, and then you get 18. So now I subtract that. And here I have 2 left over. And so I can bring another 0 down. And once I bring that 0 down, I'm looking at how many times does 9 go into 20? Well, it goes in there twice again. And then I do it again. And then 2 times 9 equals 18. Subtract them. Bring down another 0. And here I have another 20, huh? Well, it goes in there twice again. And whoa, would you look at that? If I subtract, it'll give me 2 again. So looks like 2s are going to keep going on forever. So I draw this little line above the 2 saying that it will repeat. Will not end, okay? Actually, if it's like 1 divided by 9, 2 divided by 9, 3 divided by 9, anything divided by 9 will be repeating. Write an addition expression. Let me see if I can pull this down and extend the page. Is it not going to let me? Well, it says write an addition expression and multiplication expression to represent this diagram. So I'm going to go ahead and get rid of this fun stuff up here. I'll make it a little bit easier. Well, an addition expression for 8, 8, and 8 would simply be to just add them all together. 24. And then multiplication, there are 3 number 8s. So 3 and then in parentheses 8, or 3 times 8, 24. There we go. All right. So now we're looking at problems 8 and 9, written in my beautiful handwriting. So this first one says 2 over 3 times 3 over 10. So with multiplication, all you do is just multiply across top, multiply across the bottom. You can actually think of it as one straight line across, 2 separate problems. All right. So if I do 2 times 3, it's going to give me 6. 3 times 10, going to give me 30. And then if I reduce, meaning think about what 6 and 30 can both be divided by. They can both be divided by 6. And so if I do 6 divided by 6, I get 1. If I do 30 divided by 6, I get 5. And so my final answer, simplified, would be 1 over 5. And now we look at 9. And 9 says 2 1/2 multiplied by 3 3/4. Okay, so I'm going to do a different method than the box method this time. And I'm going to do changing these to improper fractions first. All right, so I'm going to change 2 1/2 to 5 over 2. Right, if you did 2 times 2 and then added that 1, then you're going to get 5 on top. So 5 over 2 multiplied by, in this case, we're going to do 4 times 3, and then add that 3 we have on top, and that's going to give us 15 over 4. Want to have this, oh, we don't have to have the same denominator here because we're multiplying. So if we do what's on the top, 5 times 15, that's going to give us 75. And if we do on the bottom, 2 times 4, that's going to give us 8. Okay, well now we have this improper fraction. But we can say how many times does 8 go into 75? Well, I know 8 goes into 64 8 times.